This video is on factoring degree 3 polynomials by grouping. Grouping is a very fast method of factoring, however, it does not always work. I do need to add the disclaimer at the beginning. This method is very useful because it is fast, but again, it does not always work. Okay, what I mean by degree 3 polynomials is that the highest exponent in a polynomial is 3. So if you look at these four problems, I have x cubed, x cubed, x cubed, x cubed. All is my first term, my biggest term, or I guess biggest exponent would be 3 on all of these. So these are degree 3 polynomials. So when I see these, I try grouping because it's fast. If grouping doesn't work, I switch methods, which we'll talk about in another video. All right, so when I try grouping, I'm going to create a group out of the first two terms and a group out of the second two terms. Luckily here there is a plus sign before that third term. If that were a minus sign, we would need to take it into the second parentheses. You can take in a plus sign into the second parentheses. However, it's a little redundant to see a plus 9x here. It would just look weird. You can do it. It just looks a little weird. All right, so the next thing we need to do is divide out the greatest common factor from each group. From that first group, the greatest common factor would be x squared. So when I take that out, and by take it out, I mean factor it out, I am left with 3x minus 4. I'm going to do the same thing with the second group, but the second group, the greatest common factor for these two would be 3. So I'm going to keep that plus sign here. So that's the plus sign here. And I have the 3 that I divided out, and I'm left with 3x minus 12, or minus 4. Again, I'm getting that from dividing this side by 3 and this side by 3, and that gives me the 3x minus 4. All right, now you see that we have 3x minus 4 twice from each of the two groups. That is what we wanted. If we do not get that, then we cannot proceed by grouping. So because we have that, we can go on. So I'm going to take that out. It's kind of like a common term for each. And when I do that, I'm left with x squared plus 3. It's kind of like I take these out. So the factored form of this polynomial is 3x minus 4 times x squared plus 3. And if you, by now you've probably been factoring a lot, but these are interchangeable. You can switch up the order on those and it's the same answer. All right, the next problem is 12x cubed plus 4x squared plus 3x plus 1. We need to group the first two, group the second two. We have that plus sign, so we don't need to bring it in. You can, it's redundant. The greatest common factor of this first group, we can divide both of these by 4x squared evenly. When I do that, I'm left with 3x plus 1. The second group technically does not have a greatest common factor, but I'm going to go ahead and divide both of those by 1 so that when I write out my factor form, it's a little bit easier to see. So when I do that, I'm going to have plus 1. When I divide that second group by 1, nothing changes, so I'm still left with 3x plus 1, which is good because, again, we want these two factors or parentheses, I guess, to match, and they do. So because they are common, I'm going to take them out in front, 3x plus 1. And when I take them out, I'm left with 4x squared plus 1. So again, dividing out by 1 and writing the 1 just helps when I write this so I don't forget or leave it off. If you hadn't written it, so let me erase a little bit. If you hadn't written it here, oops, technically there is an invisible 1 here. It just is a little bit cleaner if you leave it in, okay? Let me clean that up so I can save my notes. Awesome. All right, next problem, I have 105x cubed plus 175x squared minus 75x minus 125. These are quite big numbers, and right off the bat, you're probably like, oh, they all divide by 5. I'm going to divide by 5 later in the problem, just in case you two are working your problems later and you forget and you do a greatest common factor at the very end. That way you can see it later. It's a little bit harder later, so I just want to show that. But right now, if you divided by 5, that would be perfectly amazing and honestly preferred. All right, so we're going to make our two groups. Notice here that third term is negative or minus 75. I am going to write a little plus sign between the two groups. If you don't, it looks like multiplication. This is just scratch work, like factoring is just scratch work for the final answer, so it doesn't really matter. But mathematically, it is correct to add a plus sign here since I'm a math teacher. I'm going to show you that. The greatest common factor of this first group would be 35x squared. No, I did not know that automatically. I had to think about 105 and 175. If you're on your homework, you can literally Google greatest common factor of 105 and 175. It will tell you. Amazing. There is also a way on your TI-84 calculator to get it to do that for you. I'll make a video about that too. If not, you're just trying numbers, and you know that it's going to be a multiple of 5 because of these 5s here. And you want to choose the greatest. If you don't choose the greatest, you're going to run into trouble. So I have 35x squared. When I divide that out of the first group turns into 35x squared times 3x plus 5. For my second group, I can divide both of these by negative 25. We do want to divide by negative because we want 3x squared here, and we don't want a negative 3x squared. So if we divided by positive 25, we would not have matching parentheses, if that makes sense. So whenever you have a negative here, we do want to divide that out. So this would be minus 25 times, and that would be 3x plus 5. So they do match. Again, if you took out a positive 25 here, they would not match, so then you'd go back and have to take out the negative. All right, so I'm going to write the 3x plus 5 on the outside. When I take those two out, I'm left with 35x squared minus 25. This is factored form. It's not best form because, like I kind of said earlier, hinted at, I can actually factor out a 5 here. So when I factor out a 5, I'm going to bring it into the very, very front. That does not change anything from about 3x plus 5, but it does change that last factor to 7x squared minus 5. And that's our final factor form, best form because we took out that greatest common factor of 5. You could do it at the beginning, that is preferred, so then you're dealing with smaller numbers. However, I chose to do it at the end just so you could see, in case you forget to do it at the beginning, you can always just factor it out at the end when you notice, okay, hey, I can actually divide these further. All right, last problem, 10x cubed plus 2x squared minus 40x minus 8. I'm going to make my two groups. There's a minus sign there with the third term, so I'm just going to add a plus sign there. Mathematically correct to do so. The greatest common factor of the first group would be 2x squared. When I factor that out, I am left with 2x squared times 5x plus 1. Greatest common factor of the second group would be negative 8. So I'm going to have minus 8. And when I divide that out, I'm left with 5x plus 1. Luckily, these are the same. Again, I'll repeat it over and over, but if these are not the same, then you cannot factor by grouping and you need to try a different method. So when I bring those out, I have 5x plus 1, and I'm left with 2x squared minus 8. Kind of like before, we notice, okay, here I can divide out of 2. That one can actually continue to factor. If we look at the original problem, we probably should have noticed that they can all divide by 2. If we didn't, that's okay. We can do it now, and I'll have a 2 times 5x plus 1, and then this factor turns into x squared minus 4. A lot of you would probably stop here, but we've been doing so much factoring lately that this one can actually continue. It's a difference of squares problem. So I'm going to keep the 2 times 5x plus 1. And then this one actually turns into x times x. To get 4, we have 2 times 2. We want the inside term or the x term to cancel, so we're going to have a minus and a plus. These are interchangeable. Doesn't matter which order. And just for the matter, like this one, we could also switch the order here and switch these two or any of them really. All right, last note that I need to make, I made at the beginning, but I just need to say one more time, note that factoring using this method does not always work. In the future, we will talk through other methods of factoring that will allow you to factor, when factorable, any polynomial. Not all polynomials factor, so I do need to also add this caveat, when factorable, but there are methods that always work. A little more tedious, this one is very fast, so it's very useful.